Mr. T here, and we are continuing our unit on trigonometry and circular functions. Today we're going to start our lesson talking about reference angles. And a reference angle is the measure of an angle between the terminal side, which in our picture will be the red side as we move the angle, and the nearest x-axis. And since we're measuring within a quadrant, the measure of a reference angle will always be between 0 and 90 degrees if we're working in degrees, and 0 and pi over 2 if we're using radians. And we'll use this prime notation to reference to indicate the reference angle of a particular given angle theta. So I want to go through each quadrant and look at the relationship between a given angle and its reference angle. So in quadrant 1, so remember this is quadrant 1, 2, 3, and 4. So in quadrant, let's list here, quadrant. So in quadrant 1, theta prime, the reference angle, is going to equal theta. They're going to be the same angle. So when we're in quadrant 1, they're the same angle. Let's move over to quadrant 2. So, whoops, grab just the end of this. So let's move over into quadrant 2. Let's get rid of these here. So now our theta is this angle, but it says here we measure the reference angle as being the angle between the terminal side and the nearest x-axis. So the nearest x-axis is here, not over here. So this angle, the measure of that angle, will be our theta prime. So if we tried to figure out a formula for this, if I knew this angle and wanted to calculate this angle, well, those two angles together when we're in quadrant 2 add up to be 180. So to get this angle, I could take 180 and subtract from it theta. So in quadrant 2, to get theta prime, I'm going to take 180 minus theta if we're working in degrees. And if we were doing the same thing in radians, this would be pi. So we would be taking pi minus our given angle. And again, that's if we know our angle ends up in quadrant 2. Okay, let's look at what happens in quadrant 3. So let's move this on around down here. And let me clean up my work here. So now we have taken our theta into quadrant 3. So our given angle's here. So based on our definition, again up here, this angle is our theta prime, our reference angle. So if we were trying to calculate that in quadrant 3, the entire angle is to here, and if we want just this piece, we've got to subtract off this 180 degrees. So here, theta prime is going to be our given angle minus 180, and if we did it in radians, it would be our given angle minus pi. And finally, let's finish up in quadrant 4. So let's rotate it around here. So now our theta is here, and let's get rid of this, and our theta prime now is this angle. So to come up with a formula in the fourth quadrant, to get all the way around here, we've gone 360, and we would have to subtract this from 360. So our theta prime is going to be 360 minus theta, or 2 pi minus theta, because all the way around to here would be 2 pi. A common mistake will be when you do the math is finding, say, this angle here, especially when this angle is narrow, but we don't want it to the nearest y-axis, we want here. Now, you can remember these formulas, which might be difficult for many of you, or as we did here, we can draw a little diagram to find our specific angle. So let's look at a couple examples. So let's look at 210 if we wanted to find the reference angle. So let's sketch a 210 angle. So 210 is going to be taking us into the third quadrant. So that is our 210 degrees. So based on the definition, we want this angle. So we have to take away that part, 180. So our reference angle is going to be 210 minus 180, or 30 degrees. Let's look at negative 225. So again, let's sketch our angle. So now we're going backwards. So that's negative 180 and another 45. So just from my talking, we said we went another 45. So our reference angle is 45 degrees. Reference angles will always be positive. So again, it was that angle there. Now let's look at some in radians. So remember, to graph the angle 5 pi over 3, we're going to divide each half of our circle into thirds. So now we can count. So we're going 1/3, 2/3, 3. I'm sorry, it was 3/3 here, 4/3, 5/3. So this angle here is 5 pi over 3. So our reference angle is here, which is going to be, it's one wedge, so it's going to be pi over 3. And our last example here, negative 3 pi over 4, so we're going to divide each of our quadrants into a fourth, or a half, I mean. So each semicircle is, sorry, my lines are not very straight today. So now we want to go negative 3 pi over 4. So that's 1, 2, 3 pi over 4 negative. So this is our angle here. Our reference angle is to the nearest x-axis right here. And that's one wedge again, so our theta prime is pi over 4. Okay. Now we can use this to find trig values for these angles, because the trig value of an angle will be related to the trig value of the reference angle. It's just that we might need to adjust for positive or negatives. So we're going to be using, to find these trig values, our special angles. Now we've used this a number of times this year, and these numbers, if we look in the first quadrant of our unit circle, would be the values. So I've listed our special angles in the first quadrant, and their sine values, cosine values, and tangent values. So let's apply reference angles and these numbers to find it for other angles in the coordinate plane. So we first want to do is determine our reference angle. So let's draw a little coordinate plane here. And since we're dealing with thirds here, we're going to again divide up into thirds. And we're going 4 pi over 3. So 1, 2, 3, 4. We're right here. So our reference angle is pi over 3. So when we go to find this, our value is going to be the same as the cosine of pi over 3, but then we have to decide whether to make it positive or negative. So we are in the third quadrant here. Now remember, cosines are related to the x-coordinate of this point here. The x-coordinate of this point is negative. We are here in this quadrant, we're negative and negative. So cosine is the x-quadrant, so this is going to be negative. So the cosine of 4 pi 3 is negative because we're in the third quadrant, and then we need the value for pi over 3, cosine. So cosine of pi over 3 is 1/2. So we get here our answer is negative 1/2. Let's look at a tangent. Negative 210, that's negative 180, and we go a little bit more. In fact, we went 30 degrees more, so our reference angle is 30. So the tangent of negative 210 numerically is going to have the same value as the tangent of 30. And now we got to figure out, should it be positive or negative? Well, the tangent in the unit circle is y over x, and we're in quadrant 2. In quadrant 2, our y's are positive and our x values are negative. So the tangent in quadrant 2 is negative. So again, we need to make this negative tangent of 30. And we'll look up in our table tangent of 30, and we get radical 3 over 3. And let's do our final example. Let's try 11 pi over 4. Divide our semicircles into quarters. Let's draw our angle in standard position. So going around to here is 8 pi over 4, 9, 10, 11. So here we're ending up here is our terminal side. So we're in Q2. This is 1 pi over 4, so our reference angle is pi over 4. So numerically, this is going to be the same as the sine of pi over 4. Now we're in quadrant 2, and sine is the y value, and y's are positive, so we want positive. So we look up in our value, pi over 4, sine radical 2 over 2. So this is going to be plus square root of 2 over 2. So these, again, what we've been doing here is finding the exact trig function of angles using reference angles and quadrant analysis. Our last part is going to be to solve trig equations. And when we are solving, back if you remember in triangles, if we're finding a missing angle, we used on the calculator a inverse trig function. But now we are in a coordinate plane setting, and it's a little bit more complicated. Let's say I wanted to know which angle had, for example, the sine of 1/2. Well, remember the sine function is the y, so this angle here would have a sine value of 1/2. But if I look at the y coordinates, I go around over here, I have another angle that has a sine of 1/2. So that angle also gives me a solution. So if I was trying to find all the angles, say in one revolution, that gave me the sine of theta equals 1/2, it would be 30 degrees, and it would also be 150 degrees. There are two solutions. And we can do that with a lot of other angles. Now, in math, a function can only return one value. So if we did the sine inverse of theta on a calculator, it's just going to give us 30 degrees. So we have to augment what we get from the calculator because it's only going to give us one of multiple answers. Again, also, if we weren't restricting ourselves to one turn of the circle, we could also have this angle around to here, which would be 390 degrees, and its sine of 390 degrees would also be 1/2. So up here, theta could be 390. We will be, when we are solving these equations, finding all the answers in one revolution of the circle. So the way mathematically we deal with that issue of multiple answers is the calculator restricts the range of answers. So when we use the sine inverse function, we're only going to get answers in that range, which is half the circle, either in degrees or radians. Now, unfortunately, for sine and cosine, those range are different, so we get different answers. So let's look at how we might apply that to solve these equations. Again, we are looking for all the solutions within one revolution. So if we work this problem here, we know a couple things. So we know here the sine of theta is negative. So that tells us that we are in, if we look at here, remember the sine is the y-coordinate. So y values are negative in the third quadrant and the fourth quadrant. So we want two answers, a third quadrant answer and a fourth quadrant answer. And we want the value of the sine, the reference angle, is going to be positive square root of 3 over 2. So if we go back to our special table here and look at sine value, radical 3 over 2, if we do a backwards table lookup, that tells us our angle, let's do it in degrees, is 60 degrees. So we know from our exact values that our reference angle is 60 degrees. So we know two pieces of information now, reference angles and quadrants. So if I draw a reference angle of 60 degrees into quadrant 3, that angle is one of my solutions. So that's going to be, we went 180 plus 60 is 240. And now let me change colors here. I draw a reference angle in quadrant 4. And we are looking now for that angle. So that is 360 minus 60 would be 300 degrees. So we have two answers here for this. Again, because it was y, we're negative in quadrants 3 and 4. Let's look at a cosine problem. Let's make a little sketch. Now cosine is related to the x letter, and x's are positive in the first quadrant and the fourth quadrant. So we have those two solutions. And from our table of special values, the cosine is equal to 1/2 for the 60 degree angle. So again, our reference angle is 60 degrees. So again, I can draw a 60 degree angle here. Now in this case, the reference angle and the angle is the same. So one of our answers here is 60 degrees. That's our quadrant 1 answer. And we need a quadrant 4 answer with 60 degrees. And that angle would be 300 degrees. Now, in these two problems, we are looking for exact solutions because these numbers are numbers that are in the table of special values. So if we have sine, cosine equaling those numbers, or a tangent equal to these numbers, we can get exact values. These numbers are not exact values, so we're going to use the graphing calculator to get us our reference angle. So let's work this problem here. Again, we're going to want to start with, at least I like to start with a little diagram. And our first thing we want to do is sine is related to the y. So we want to know where is the y negative. And the y is negative in quadrants 3 and 4. So we need two solutions, one in quadrant 3 and one in quadrant 4. And let's turn on our calculator. Now I'm going to work these in degrees, so I've got my calculator in degree mode. So I'm going to do second sine inverse of negative 0.8. And I get the answer of negative 53.1 degrees. So that's going to be my reference angle, and I'm just going to make it be positive, so 53.1. So I need a quadrant 4 answer, which would be the negative 53.1, but we don't want our answers as negative. And I need a quadrant 3 answer, also with 53.1. So I need to figure out now this angle if I do my quadrant 4 angle. So quadrant 4 is going to be 360 minus 53.1, which is, let's calculate here, 360 minus 53.1, and we get 306.9. And here, for my quadrant 3 answer, it's going to be that angle. So to here's 180, and we're going another 53.1, so it's going to be 180 plus 53.1, and I get 233.1. Again, those are my two answers to this equation here. And again, one of them is a quadrant 3 answer and a quadrant 4. Now notice neither of these answers are the answers that we got here originally from the calculator. So you have to use your brain and use our quadrant analysis to get the correct answers. And our last problem here, we're going a little long in this video. Same thing. Now x, we need to know where the x is negative, and that's going to be in quadrant 2 and quadrant 3. Let's see what the calculator gives us. Of negative 0.6. So that gives us a 126.9. So in this case, that is one of our answers. That's our second quadrant answer. Now we need to figure out our third quadrant. So I need to know the reference angle. So this angle in here is our reference angle. So the reference angle is going to be 180 minus what we just found there, or 53.1. So our reference angle is 53.1. So we need a third quadrant angle. So I've got to put 53.1 here. So to get to that angle, we have to go 180 plus 53.1. We just did that calculation down here. So theta is 233.1. So we've covered today primarily focusing on reference angles and how to find reference angles and how reference angles can be used to solve trig equations. So good luck and see you soon.